All right, hello and welcome to lesson 1-6 and 1-7. Seventh grade math, we're doing problem solving today. Today is going to be a little different kind of a lesson. Our lessons are normally very structured and set up where I'm going to give you some input, going to give you some information. Today, you know all the information, you know all the pieces. Now we're just going to put them all together. So we're doing lesson 1-6 and 1-7, which is problem solving. All right, so let's go ahead and get started with our anticipatory set. Now, our anticipatory set today, I got to talk a little bit about my trip out to Denver. All right, so as I'm sure you all know, because I'm not standing in front of you, I'm on a screen, is that Mrs. Berry and I moved to Denver. So when we decided this, so it's over the summer, we decided we were going to be moving to Denver. We had to decide, okay, we're living out in California now. What do we do to get out to Denver? What do I do? There wasn't really any like rules or anything. No one really had an idea of what I needed to do. Oh, it's a bad United States. Florida looks a little weird. Okay. So let's just pretend that's the United States for now, okay? We're just going to pretend. So right now, or at this time, we were living about here, about where a lot of people from this area from. California's right here, kind of, whatever. That's the United States. So we were living there, and you know, next to California, there's Nevada here. There's Arizona, New Mexico, around here. There's whatever. That's roughly what the United States looks like. It's terrible. Mr. Bear's not an artist. Okay, but anyway, when we decided to move to Denver, we had to decide we had to get from here, and our new home was here. And we had to decide how are we going to get there? Now, we couldn't just fly because we had a ton of stuff we had to move too. Everything we had to move. So what we had to do was we had to think about all the different pieces that went into this puzzle. It was a problem we had to solve. How were we going to solve this problem? So the first thing we had to think about was how are we going to get our stuff out there? How are we going to get our stuff out there? So there were a few options of what we could do. We could ship it on a plane. They could take it all and ship it. We could get a U-Haul, which is like a truck you can rent. Now, if we were going to decide between these two things, we were looking, okay, we can ship it or we can use a U-Haul. And actually, it wasn't even a U-Haul. You could say a U-Haul, but it's a rental truck. Shipping it was going to be very expensive. We weren't going to use that. So we were going to go either with a U-Haul. Now, if we were going to do a U-Haul, we could either do the actual U-Haul, but there's also Penske. There's also Budget. There's all these other companies, and we had to decide what's the best price, what's the best value. We had to get from here to here. There's U-Haul, there's Penske, there's Budget, different trucks, different sizes. Now in U-Haul, you could get one that was 17 feet. So this was 17 feet. And let's try and draw the top of a truck here. Oh boy. Okay. Whatever. That's a truck. So we could get a 17-foot truck. For the same price that at Penske, we could get a 15-foot truck. So it made more sense for us to decide to go with a U-Haul. So we decided, okay, no Penske, we'll go with a U-Haul. Okay, now we had to decide how to pay. There's several different ways to pay with U-Haul. You can decide to pay by time, by mileage, or you could pay by time or by mileage, and then you also had to figure out how much gas cost. So we had all these three things to figure out. And then once we decided that, we need to decide, okay, so we're going to drive this truck out here. Is it better to do it by time or by mileage? Well, it's going to take more than a day to get here. So we have to figure out where we're going to stay along the way. So what we had to decide at that point while we're thinking about all these other things was, are we going to, do you think that we're going to stay, are we going to try and stay in some hotels? Are we going to stay with friends? Are we going to stay in the truck? Which, no, we're not going to stay in the truck. Hotels or friends. Now, do we have friends that live in all these places? So what we eventually decided was we were going to use a U-Haul truck. And since the U-Haul is kind of an expensive choice, we were going to try and not stay in hotels and stay with friends. That meant we found a friend who lived here in Las Vegas, which is on the way. If I was going to drive to Denver, I would try and go through Las Vegas and this way up over the Rocky Mountains and then to Denver. Now, we were like, okay, so we'll stay with a friend here. We'll have to figure out the rest. But then we had to think, okay, we're driving this giant U-Haul truck. Is the U-Haul truck, will it be able to get over the mountains? It's going to be weighed down with everything that we own. Is it going to get over that? Okay, so then we said, all right, well, maybe there's a different way. And we found actually we had a friend's parents who lived in Arizona. So instead of going this way, we decided, okay, let's go ahead and let's break off and now go this way. Okay, well, that changes the distance between here and here, and our mileage is going to be different. Our gas cost is going to be different. And then we're trying to figure out where to go from here to here. So we went ahead and we stayed in a hotel right here. Okay, so that's one hotel, and that's a little bit less mileage now because we're going this way. And then we figured we had to drive all the way this way and stop here, but we stayed with a friend. And then we decided, okay, so we're staying with a friend for 2 nights and a hotel in 1 night, and then we're going to go by mileage, and finally we made it up here. So that's pretty confusing to try and figure out. Every problem you can do, it's got a lot of different things you got to think of. So when we're doing things in real life, you got to take it step by step. So let's go ahead and move on. I don't want to talk about that. It stresses me out. Enough with the moving talk. All right. So let's go ahead and get right into it and start with our standard. And today's standard is going to be a long one. I believe we wrote it down already, but you're going to write it down again. So here we go. Our standard today is 7.NS.1C. So this is 7th grade, the number system, standard 1C. And what that says is understand P plus Q as the number located a distance, the absolute value of Q from P. In the positive or negative direction, depending on whether Q is positive or negative. Okay, so that's the first part of our standard. Oh, I'm sorry. Understand P plus Q as the number located at distance Q, the absolute value of Q, from P in the positive or negative direction, depending on whether Q is positive or negative. That's a little confusing. We've talked about this one before. We're going to go ahead and we'll break it down in a bit, but let's move on. And the second part of our standard says, show, actually, you know what? I'm going to use a different color here. This is how we can use different colors to our advantage. That's the first part of the standard. We're getting into a different part. I'm going to use a different color. Show that a number and its opposite have a sum of 0. And this also means that they are additive inverses. And then the final part of our standard, there's one final part of our standard. We're going to write down, I'm going to use a different color again for it, and say, interpret sums of rational numbers by describing real world contexts. Okay, so that is our massive, gigantic standard. It's very important that we have it all down. Now, we've talked a little bit about this first part before, and it's worded pretty confusing. Understand P plus Q as the number located a distance Q, the absolute value of Q, from P in the positive or negative direction, depending on whether Q is positive or negative. Now, real quick, as just a refresher, because that's a very wordy linguistic, if you're linguistic, you probably get that a little bit better than everyone else. Well, let's do a quick little number line. Okay, and let's say that this is 0. Okay, and let's pretend that P equals 2 and Q equals, let's say, -1. So P, actually, let's not even go negative right now. Let's just say 2 and 4. So let's say that P plus Q, so that means 2 plus 4. So if we go here, and this is 2, that's P plus Q as the number located at distance, the absolute value of Q, well, Q is already positive, so that's fine. 1, 2, 3, 4. This isn't 4. The answer is going to be 4 further than that 2. So that's just a brief, quick thing about what that first part means. It's a little confusing when it's written out with words. It just means if there's an addition problem, it's just how this distance from P. Okay, and the second part should be kind of easy, and it's not as confusing when it's worded. Show that a number and its opposite have a sum of 0 and are additive inverses. Okay, so if I have 2 and -2, those will work out to be 0. Because when you write it out as 2 plus -2, you're actually going to be going back, and it's going to cancel each other out, and they're going to be additive inverses. Okay, so those are the two that we've kind of gone over. Now, what I want you to do is take a different color, and you can sort of put a box around this last part, because that's what we're going to focus on today. The sums of rational numbers by describing real-world contexts. Real-world contexts. Just like up here, this problem is super confusing, and we're not doing that, but it's going to be a real-world concept we're talking about, and we're going to use that real-world example to go ahead and direct our problems today. So, like I said, this is a slightly different math lesson because I'm going to show you, we're going to fit, I only have a little bit of my paper left here, but we're going to be able to fit our input in here. So, let's just go ahead and put input. And first of all, I have just one quick language of the discipline. And our quick language of the discipline is going to be range. Range. And range, what range is the difference between the highest recorded value and the lowest recorded value. That's the only thing we need to really know. Now, you also may have heard that before. We've done ranges before in different grades. However, just make sure you have that down so you know the difference between the highest recorded value and the lowest recorded value is going to be the range. Now, for our details, we have one detail. We're going to fit it here on the very, very bottom. All we're going to write for our details today is that we are going to, in all of these problems, use our logic. Math is like a puzzle. These math problems we're going to get, they're going to give us a lot of information, and we need to figure it out. They're designed to be confusing. They're designed to have a lot of different things you have to keep your mind wrapped around. You need to figure it out. Just like up here, Ms. Barry and I decided to do this. It is a huge task to try and move your entire life to a different state. There's a lot of different things you have to think about, a lot of different things you have to choose between, a lot of different ways to find your answer. Same thing with what we're doing right now. We're going to use our logic and we're going to find the answer. So we're going to go ahead and start with modeling. Okay, our input is just that we are going to take what we know and we're now going to use modeling. So, brand new piece of paper for me. I'm going to go ahead and say modeling. And starting off with our modeling, we're going to start off with a few easy ones. Right next to it. Easy. Okay, these ones are not going to be difficult. These are going to sort of get us warmed up for what we're going to do here in a second. So let's start with a few easy ones. And the first question, I'm going to write down, first modeling question, is going to be, what is the distance between 6.4, 6 4/10, and negative 8.2, negative 8 2/10. Okay, that's it. First one, like I said, it's going to be nice and easy, and we're going to find the distance between these two numbers. Now, the way we always like to do this, the best way for us to do this, or the way I like to do it, is to sort of view it on a number line. I'm much more of a spatial person than logical mathematical. So spatial is where I want to kind of keep all of my information. I want to view it spatially. So the best way to do this is on a number line. So I'm going to go ahead and draw a number line. And on this number line, I'm going to go by twos, so it's nice and easy. The 0 is going to go right here. And then on this side, let's see, 1, 2, 3, 4, 5, 6. Yeah, we'll go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Okay, so that is my number line. I can visually look at this problem. What is the distance between 6.4 and negative 8.2? Okay, so let's look. First of all, we're going to take the first number, 6.4. It's going to be 1, 2, 3, 4, 5, 6. And somewhere in the middle, about right there, 6.4. I'll label it as 6.4. I'm going to take a different color here, and I'm going to go negative 8.2. Now I'm going negative. Negative 1, 2, 3, 4, 5, 6, 7, 8. 8.2. It's going to be close right there. Now, I'm going to look for the distance between these two. Now, if I look right here, it's going to be more than 6.4. We're trying to find the distance between these two things. So now I can sort of just count, but this visual gives me a nice idea that it's not going to be, if I look at it, okay, well, 8.2 is about 2 higher or 2 more value than 6. I'm not going to worry about that. Sometimes numbers can be confusing for me. So I go here to my number line, and I see that it's going to be this 8 and then this 6. I'm looking for the value of what the distance is. So the way you could always do it is one value, you're finding the difference. So one value minus the other value. So a great way to remember it is to find the difference. And if you're finding the difference, that is subtraction. If you're finding the difference. So let's see what that will look like. If I have 6.4, which is my first number, 6.4, and I subtract, from that I'm going to subtract, because I'm finding the difference. I'm subtracting the second number, negative 8.2. So what I'm going to have to use, I'm going to have to use a parentheses here, negative 8.2. I'm going to figure out what that equals. Now, if we remember, when you have a negative and a negative, when you're negative, negative right there, that's going to say, it's going to change it to 6.4 plus 8.2. Now, we get to just add these, and that's pretty easy. 4 and 2 is 6. 6 and 8 is 14. So let's now double check visually, because for me, I understand that that works, but it makes more sense to me visually. Let me just count. So let's say this is about 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and a little bit extra on either side. So I have to be correct. Visually and logical mathematically, it worked out. So that's just one, and that's pretty easy. That's not that we're not thinking about too much there. So now let's go to the second one. Now let's use those real world concepts, okay? Right here, this is very much math. Thinking on a number line, that's not real world. Let's use a real world example. How about a jet is flying at 32,000 feet. A hot air balloon is floating directly below the jet at 13,000 feet. How far apart are they? Now here's something a little bit more real world. All right, we're talking about we have a jet. So if we want to look at this spatially, there's some sort of a jet flying right here, which again, Mr. Barry's not an artist. A jet flying, and below that jet, there's a hot air balloon. Oh boy, man, that's not a good whatever. Okay, so there we go. There's a jet and a hot, oh, I can't even see it. There's my terrible balloon. There's a jet and a hot air balloon, and they're saying the jet is at 32,000 feet, and the hot air balloon is at 13,000 feet. The ground's down here at 0. Now then what they're saying is they're asking how far apart are these two things. So we just need to find how far apart that is. And again, look at that. It's going to be the difference. What is the difference between how high this one is and how high this one is? How are they related to each other? So the difference now in this one, once we can see that, we're just trying to figure out what is the distance in right here. So 32,000 minus 13,000. 0, 0, 0. 2 minus 3 can't do it. 12 minus 3, 9. 2 minus 1, 1. So the difference or the distance in between these two right here is going to be 19,000 feet. So our answer is going to be 19,000 feet. Okay, again, shouldn't be too difficult. We're just being able to look at these simple problems here. Let's go ahead and do two more of these easier ones. The next one, I'm going to go away from the real world context for a second. And we're going to go to number 3, which is the distance between negative 380 and 120 on a number line. Okay, again, this isn't the real world context anymore. This is now back to that number line. Now, if you remember from up here, I said it's always going to be find the difference, right? So the first number subtracted by or minus the second number. So let's try that again. If that worked that first time, it should work the second time. So here's my first number, and here's my second number. So I'm going to have negative 380 minus 120. Okay, so if I'm going to subtract this, negative 380 minus 120, my answer is going to be more negative, right? So let's go ahead and see. Negative 380 minus 120, 0, 8. Now remember, we're going more negative. So these two negatives there, but we're going to be adding this together. We're going to be how much more negative? Right, if we're here on a number line, this is negative 380, and we subtract 120, it's going to be further in the negative. So we just need to remember that. We're going more negative than 380, so we have to add this. 3, 4, 5. So we're going to be at negative 500. Because 380, negative 380 minus 120 is going to be even more negative and get us negative 500. Now, can the distance between negative 380 and 120 on a number line be negative 500? No, not really. Let's take a quick look at a really quickly sketched out number line. Let's say this is 0. This is, and it's not going to be to scale, negative 380, and this is 120. If we're looking here, the distance is not going to be negative. So really all we have to do is just remember at the end of this, we always want these to be the absolute value. So our distance between these two numbers on a number line is going to be 500. Positive 500 because we're just looking for the value of this. We don't care negative or positive. We just want this amount of space. All right, so that's number 3. Hopefully you're staying with me here. We're going to go ahead and do another one last of these sort of easier ones before we get into ones that are going to ask a little bit more from us. So for number 4, again, we're going to go into those real world contexts right now. Number 4 says, Mr. Berry did a cannonball off a diving board. That was 1.5 meters above the water. He went 3/4 of a meter below the water's surface. How much distance did he cover? Okay, so if Mr. Berry did a cannonball off a diving board that was 1.5 meters above the water, he went 3/4 of a meter below the water's surface. How much distance did he cover? Okay, so let's see. If we have, let's go ahead and make a little spatial thing here. If we have a diving board here, and we have a nice little set of water right here, then I'm over here and I did a cannonball. I start there, I go down, and I went into the water. And let's say I make a big splash here. All right, great. So if Mr. Berry did a cannonball and it is saying that I am 1.5 meters, 1.5 meters above the water when I start, then right here, this distance is going to be 1.5 meters. Then as I go into the water, I travel 3/4 of a meter into the water. How much distance did he cover? Well, let's think. I go 1.5 meters and then 3/4 of a meter underneath. So this is going to be, what is the total distance here? So that's just going to be 1.5 plus the 3/4 of a meter that I go under the water. And what does that equal? Again, we're just using our logic. We're thinking, if this is what I do, and then I go under the water this much, it's just going to be an addition problem of getting these two numbers together. Now, if I do this, I can't add these yet because I need them to be the same. So I'll just go ahead. This is easy enough. 2 can become 4 by multiplied by 2. Same thing to the top. So now I have 1 and 2/4 plus 3/4 equals 1 and 5/4, which equals 2 and 1/4. So once I do my addition of my fractions right there, I will say that my total distance covered from my cannonball to underneath the water is going to be 2 and 1/4 meters. So again, we're using our logic and we're just understanding that we need to solve a problem, a real world problem. Okay, here we go. Let's get into the stuff that's going to be a little bit more difficult. There's going to be some more writing involved here, so get yourself ready. So these are now going to be, let's label these as hard. Okay, let's start with number 5. Now this one, there's going to be some writing, okay? All right, now this was actually pretty correct. Mr. Berry is getting used to Denver. Okay. Now in Denver, there are 3 roads. We have Blake, Market, and Larimer. That run north and south. Okay, that's our first part of our clue there. They each meet 16th Street that runs east and west. Okay, so again, starting to set up a problem. We have a piece up here, there's 3 roads, there's a piece right here. We know the directions these streets are running. However, it's going to give us even more. Blake is 3.4 miles west of Market. Larimer is 4.3 miles east of Blake. Now you're starting to see we have a lot of stuff to put into this, a lot of things that are going to change what we do. And the final thing we're going to say is describe Larimer with respect to Market. Okay, now this is a very linguistic question, right? So when we're looking at this, it says a lot. There are 3 roads that run north and south, and these are the 3 names. They each meet another street that runs east to west. Blake is this distance from Market. Larimer is this distance from Blake, and this one's west, this one's east. Describe Larimer with respect to Market. Now, that's a lot of stuff to keep in your head at once. We have to do work here. We have to show our work. So, again, I said I'm very spatial. Now, in a question like this, everyone should be spatial because there's not much else we can do. We have to sort of draw an image, draw a picture to help us out. Okay, and as we start to draw the picture, it's going to help us start to understand what this is asking us. The main question is we're describing Larimer with respect to Market. How far is Larimer from Market in which direction is basically what we're going to want to know. But there's a lot of things we need to do before we get to that point. So we're just going to use our logic. Mr. Barry's getting used to Denver. That's the question being set up. You don't need to think about this anymore. It's long enough as it is. If there's a part like that, you can just ignore it and get to the part where it's going to ask us things. Now there are 3 roads. Okay, 3 roads. Blake, Market, and Larimer that run north and south. Okay, I can do that little chunk. There are 3 roads, these 3 roads that run north and south. I'm going to do that chunk right now, and I'm going to take a lot of space as I do it. 3 roads, so let me put a little north. The directions are going to be important here. So north is this way, east, south, and west. So these 3 streets are going to be running this way, north and south. Okay, so I have 3 streets, one right here. I'll put one right here. I'll put one right here. Now, I want to label them. I want to go Blake, Market, Larimer. But I can't do that because I don't know which one is where yet. I just am going to leave it at 3 roads that are north and south. And these are the names. I'll have to remember those names later. They each meet 16th Street that runs east and west. Now here's east and west, okay? I'm just going to draw a line. They each meet that street. And I know what that street's called. This is 16th Street, okay? So they each meet this 16th Street that runs east and west. I got that part, okay? So to clear it up a little bit, I'm just going to go ahead and put an underline under this part because I've done that part, and I'll even just box it off. I got that part done. I just need to name my streets and then know how far they are. Let's go to the next part. Blake is 3.4 miles west of Market. Okay. Blake, one of the streets, is west of Market. Okay, so in this, Blake, I'm just going to sort of write it out to myself over here. Blake is west to this side of Market. So Market's going to be, if Market's this one, Blake could be this one. If Market's this one, Blake could be this one or this one. Okay, so Blake is going to be one of these 2 streets. I'm not sure which one yet, but Blake will be one of these 2 streets. Blake cannot be this street. If Blake is this street, it can't be west of another street because west is that direction. Okay, again, we're just using our logic here. We have to use our minds and understand these pieces of this puzzle. So Blake, I'm just putting this little note on the side saying Market's here, Blake will be on this side. Larimer is 4.3 miles east of Blake. Okay, so now if Blake's here, Larimer would be over here. So Blake's going to be on one side of Market, and Larimer's going to be on the other side of Blake. Got a tough situation going on right now. So Blake needs to be west of Market, and look at this. Blake needs to be west of Larimer. Blake is going to be west of Market, and Blake is going to be west of Larimer. So there's only one option I now have for Blake. If it's west of both of the other streets, then this is going to be Blake. Okay. Now, I have Market and Larimer. Now, Market is east of Blake, and Larimer is east of Blake. That does not help me. So I need to decide which one is further east. Which one's further east? If I look up here, Blake is 3.4 miles west of Market. So that means Market is 3.4 miles east of Blake. So this is 3.4. And let's see, Larimer is 4.3 miles east of Blake. Which one's further? Larimer. So the furthest one's going to be Larimer, and this middle one will be Market. Okay, now I have my image the way I want it. Let's go ahead and put in the distances. Blake and Market is what we're talking about. Blake with respect to Market. And Blake is 3.4 miles west of Market. Okay, Market's here, Blake's here. This middle part is going to be 3.4 miles. Okay, that's one piece. Larimer is 4.3 miles east of Blake. Okay, so now Larimer and Blake we're talking about. And this is going to be 4.3 miles. Okay, I've got almost everything figured out. Let's see now. The last question, the question is saying to describe Larimer with respect to Market. The one we do not have yet. We know this distance and we know this distance, but now that I know two distances, I can find that third distance. If the whole thing is 4.3 and I don't want the 3.4, this is a subtraction problem. I figured it out. I'm going to have 4.3, which is the distance of the whole thing, and then I'm going to subtract the distance between Blake and Market, which is 3.4. 3 minus 4 I can't do. This whole thing, this is going to be 9, this is going to be 0, and I drop my decimal point. So the distance between Market and Larimer is going to be 0.9 miles. Now, I'm not quite done because it says describe Larimer with respect to Market. So now I have to write it out as a sentence. Larimer is 0.9 miles. Now, am I going east or west? Larimer is east or west? Larimer is east of Market. Okay, and now I have my answer. A lot of work, a lot of crossing out things that I already know, finding pieces. I like questions like this because to me it feels like a puzzle. It gives me a few clues, and then I need to go through and find it myself. Okay, so let's go ahead and do another difficult one. Not as difficult. I started out with the hardest. Now this next one is going to be where we're using our language of the discipline. We haven't used that one yet, right? We haven't used the one that says range yet. So let's go ahead and do one for range. We're going to do number 6. And number 6 is just going to be Denver temperatures in December. And then it's going to have a little chart. Denver temperatures in December. Okay. And the temperatures that are recorded are -3, 7, 9.5, -1, 0, 8, oh, one more, -3.5. So those are the recorded temperatures for Denver. The question is going to say, what is the range of temperatures? Okay, so we can look at this one. Now, if we're looking at this one and this one of these is definitely more difficult. This is more difficult. A lot more pieces, a lot more moving parts. This one, we just need to know what range means. We still need to use our brain. We need to figure out what important parts of information are, but we already know what range means. And range, if we go back to our very beginning, is the difference between the highest recorded value and the lowest recorded value. Okay, no problem at all. Let's go ahead and take a look. My highest recorded value, if I look at all of these, is going to be 9.5. And what's my lowest? -3, okay, low. -1, no, not lower. Now, -3.5. And I need to find the difference between these. The difference means it's a subtraction problem. So 9.5 minus -3.5. And if I remember, when there's two negatives, it's going to be a positive. So it's actually going to be 9.5 plus 3.5. If I write that out on the side here, so it makes it easier for me, I'll line up the decimals. 0, 1 here, 13. Drop my decimal in. What is the range in temperatures? 13 degrees. The range will be 13 degrees. It varies within -3.5 and 9.5. To look at this as well, we could go ahead and put it on a number line. Let's say 0 is here, 2, 4, 6, 8, 10, -2, -4, -6. Okay, on this, if we want to see the range, all of these will fall into the range between the highest and the lowest. The highest is over here. The lowest is -3.5, about right here. So that's 13 different numbers on the number line. Okay, so once we have that one, let's do one more. A last difficult one. And this one's going to be using a formula. I know we've used formulas in the past, but again, when we're using these real world contexts, we're going to need to make sure that we're focusing and getting all these pieces. So, Katie sold homemade art Oh man, I spelled homemade wrong. Now I can't figure it out. So we'll just say she sold art at a fair. The formula P equals R minus C shows the profit, which is the letter P, made. How much profit? If the profit was $38.41. Good job, Katie, getting $38.41. Well done. And the price of the art was price of the art, which I'm going to say, sorry, I forgot to put it in there, is what R stands for, was $80.47, how much did the art cost to make? C. Okay, so again, gives us some different rules, different ideas, things we need to consider. But this time, it's a little easier because it gives us a formula. So we are going to just basically fill in for P equals R minus C. So it cost Katie a certain amount of money to make the art. Whatever she sells her art for, she already lost this money. So whatever she sells the art for, she doesn't make that money. It's that minus how much it cost will give her how much she actually made. So her profit, we know what P is. If we look up here, profit was 38.41. And we know what R was. R was 80.47. So now let's just go ahead and fill that stuff in. So it's going to be 38.41 equals 80.47 minus C. Whatever C is. And that's what we have to figure out. Now, there are several ways to do this. Different ways to do this. Logically, mathematically, remember, math can happen so many different ways. Logically, mathematically, we could add C to this side and add C to that side, and then subtract 38 here and subtract from 80 there. So let's do that one real quick first. Logically, mathematically, we know we want to keep the equal sign, keeping these two sides equal. That just is telling us that this side is the same as this side. So the first way we can do it is I can just say, you know what? I'm going to get C over to this side. So I'm going to plus C, so that crosses that out, and I'm going to add C to this side. So now the new thing is going to be 38.41 plus C equals 80.47. So I can do that. And then I can subtract 38.41 and subtract 38.41, making sure I'm keeping both sides equal. Now it's going to say C equals 80.47 minus 38.41. Oh, now it's just a subtraction problem. And then you can go ahead and solve our subtraction problem. 7 minus 1, 6. 4 minus 4, 0. Put our decimal point right there. 0 minus 8. Now it's 2. 7 minus 3. 4. $42.06 is what the art cost to make. Now, if that's not a way you want to do it, you can always do it that way, but there are other ways. Let's just look at it. Let me write it out one more time. 38.41 equals 80.47 minus C. Okay? So let's just look at it here. There's a different way I can look at it. If I'm just using my logic, if I don't like this whole mathematical way of doing it, just use my logic. Oops. Yeah, there we go. Okay, good. So if I'm looking at it, she made $38. She brought in $80. Whatever it cost is going to be subtracted from that. Right? And I can think about that logically and say, you know what? I know that she made that amount of money. But she didn't get to keep all of that money. Now, if you don't want to do all this thing, you just need to logically know that if she had $80.47 and something was subtracted from it, and her final profit was $38.41, I just need to fill in this gap here. Think about it like a puzzle. 7 minus what is going to give us 1? Well, 7 minus 6 gives us 1. 4 minus something gives us 4. 4 minus 0. 0 minus something gives us 8. Well, I don't exactly know what would go there yet. 8 minus something would give us 3. Well, that would be 5. Let's see how this is messed up right here. I don't know how this would go. So this would become a 4. And we have to figure it because this would be now a 10 and this would be 2. So that's one way. And I know that for me, that doesn't make sense. But for some of you, that might make a little sense. And finally, since we know that addition and subtraction can be the same thing opposite ways, you could just do it by saying, flip this around and make it a lot easier on yourself. This, for me, confusing. What I would do is, and this is the way I would do it if I was solving it on my own right now, I'm not just teaching it, the way I would solve it, the way I like to do it. If I look at this right here, I know that this also means, since subtraction and addition can go back and forth, I know that if I have 38, 41, and the other number is 80.47, I know that I just need to add something to get there. Now this one makes much more sense to me. 1 plus what gives me 7? 6. What plus 4 gives me 4? 0. What plus 8 gives me 0? Well, that's the only thing that can happen there is 10. So I'm going to go ahead and put a 2 here, and that would put a 1 up there. This is now 4 plus 4 would be 8. And for me, that makes sense. So there's 3 different ways that we did that right here. Whatever works for you works, but we're just making sure we're using our logic. Understand what it is asking. All right. Now for your guided practice. Let's go ahead and write our guided practice. You are doing lesson 1-6, guided practice. And lesson 1-7, guided practice. And remember, that is assigned on your Pearson Realize account. And then for independent practice, I'll put that over here. Independent practice. You are going to front row ed. And you are going to do standard 7.NS.1B and 1C. And I know it's also written on our assignment in the Google Classroom. So that's your assignment for today. Remember to use your logic. All of this stuff, this is math, but it's all logic based. You need to use what you know to solve it in any way that you want. Math can be figured out in millions of different ways. Use the way that works for you. Just make sure you are thinking about it. You are using your logic. All right, have a great day. Go Buffs.